Cool. That's me. What is data science and how are we bringing Python into this? Data science is the art and science of transforming data into insight and strategy. It's a combination of both sides of your brain. You're taking the artsy, creative, exploratory, communicative side, and you're taking the rigor and mathematics and numbers and this analytical approach. And together, you're taking those two sides of your brain together, and you are taking data in whatever format it happens to be in, be that a CSV file, be that information on a website, be that kind of survey data. Sometimes you'll even go out into the field and gather this information yourself. And then what do you do with it? You somehow need to take this information, which has been being generated around the world in an accelerated way for the last 30 years, and you need to transform that into insight and strategy. Just by the by, this was in 2012 that IBM stated that 90% data had been produced in the last 2 years. So if you imagine the period from 2010 to 2012 produced 90% of all data that had ever been captured in the world from all years historically to 2012. That's just so mind-blowing. Literally from 2010 and before that, all of that information that had been captured, there was 9 times that produced in the 2 years from 2010 through to 2012. Just so mind-blowing. And with all of this increasing data, there is software and technology to back up what's happening. And so somehow we need to be taking this data and applying the software with algorithms in order to produce insight, take that insight and develop some kind of strategy. So Explore drives a real-world readiness through the current advances in data science. We prioritize an industry relevance, and we see the Explore stack well represented across 20,000 Kaggle data scientists. So this was the most recent survey that Kaggle has done. Kaggle is essentially a machine learning pairing platform. So it'll allow companies to post problems, and those problems by many teams of data scientists across the world. So just as a representative idea of where these data scientists come from, so out of these 20,000 respondents, they are distributed all across the world, some being represented in South Africa, a very high number being in India, and the US in particular. But as you can see, this is across the world. Kaggle is a global competition or data science competition platform. And I've linked the source over here so that you can go and see it if you would like. But going through what is listed in this survey, the top used IDE is JupyterLab, with 74% of data scientists actually using this. And this is what we're using in Explore to actually interface environment. The top cloud computing platform with almost half of participants on Kaggle using it is AWS. BI tools, Tableau and Power BI. So Tableau, not so much covered in this course, but Power BI will be. And what about Python itself? Python-based tools continue to dominate the machine learning framework, with scikit-learn as essentially a Swiss Army knife applicable to most projects. It is the top 4 in 5. Okay, it's in the top 4. It's in the absolute top of all known kind of libraries that can be used, with 4 in 5 data scientists actually taking advantage of the functionality of this incredible platform. So this is going to be something that we're not going to be touching on too much throughout this fundamental data science, Python with data science sprint, but scikit-learn is going to be one of your key tools as you go into the machine learning sprint, which is coming just after visualization. So why Python? Python is a 3rd generation open source interpreted language. Open source in that all of the code that backs it up is freely available, which also means that it's very easy to find problems online that have already been tackled and solved by other data scientists across the world. It's an interpreted language as opposed to a compiled language, which means that you can run it line by line as you go through it. And Python has been growing in popularity. It's become the primary language used by data scientists. This is a survey coming from LinkedIn in April 2019. So yes, it's about 2 years old. But what's quite interesting is since maybe 2015, R and Python have been very, very strong competitors with each other. So R, a bit more of a statistical homework, Python a bit more on the computer science edge, and it allows an integration of a whole variety of other tools as well, be it web development or plug and play visualization. There is so much that can be done across any software, to be honest, but Python in particular has had a lot of support from the data science community. And even though R and Python were strongly contested in around 2015, 2016, Python has slowly and surely been taking the lead. And this is only 3 years after they were strongly contested. At this point, Python is even more well-renowned across the industry. But yeah, just out of interest, Python, SQL, Jupyter notebooks, and AWS. So in the top 6, actually TensorFlow as well. So in the top 7, Explore will be covering and touching on 5 of those and giving you a bit of a domain-based expertise in each of those. Python has accelerated way past statistical learning R in, and this has been as data science has incorporated web applications and machine learning at scale. So R is really fantastic if you are doing specific statistical based functionality. But Python has really become quite a bit more useful in terms of how well it integrates all of these different components together. Python is versatile. It allows easy integration from web development to data processing, analytics, and data visualization as well. And it's used across FANG as the data science language of choice. Essentially an acronym that was coined in around 2013. And it's sort of the summation of leaders in their tech industries that are so far ahead of all of their competition, they essentially own the industry. So FANG standing for Facebook, Amazon, Airbnb, Netflix, Google. Well, previously Google, now often referred to as Alphabet, considering that Alphabet is Google's owning company, whichever way the English works. So just a few kind of ideas of how Python is used by some of these leaders. Google pioneered open source deep learning framework TensorFlow in Python, which is one of the components, one of the tools that we're going to be using through this course when we hit the machine learning sprint. In fact, the creator of Python, Guido van Rossum, he himself worked for Google for 8 years from 2015 to 2012. Netflix, Python has been used extensively from training machine learning models for everything from recommendation algorithms to artwork personalization and marketing algorithms. So if you consider some kind of testing approach to see what is going to work, how do we develop some kind of graph that and strategizes how what one individual has watched on Netflix should impact future recommendations for them. You guys have all experienced this if you have watched any kind of online platform, any kind of series or movie streaming. You will have encountered these recommendation algorithms that say, because you watched this, we recommend this other thing as well. It's not just as simple as that. That's what they're showing to you so that the insights become interpretable. But there's actually so much calculations, merging of different data sources Netflix has built to consolidate that into a simple recommendation and bringing it through to you as the user on an interpretable level. Out of interest, the recommendation algorithm that Netflix settled on was found through a a competition that they placed on Kaggle itself. And they also took the second top performer. They didn't take the top performer because it was too complicated and too difficult to actually implement, which is going to very quickly lead us on to the next topic of this little introduction to Python, which is about how you choose the right algorithms that you want to be using. But for now, back to this. Airbnb, another one in FANG, they built Airflow. This is an open source work management platform built in Python from the ground up. And what Airflow essentially does, it allows you to run tasks in series, one after the other, which are potentially dependent on previous tasks. Sounds very simple, and in essence, it is. It's a very simple concept that is being put into play, but it's incredibly powerful. And this allowed me in my previous job to work with my team to build a call it a implementation of Airflow, where we built a extraction, transformation, and loading process where we could take information in its raw form, construct it, transform it, and take all of this data, merge it into an actionable set of data in a, it was actually in AWS, it was in a EC2 instance, so that's Elastic Cloud Compute, but essentially in this EC2 instance, we did all of this computation, and we did it in such a way that it was structured and repeatable. So every single morning at 2 a.m., workflow would run. Everything all right? Just heard a, okay. There was a workflow manager. There was a workflow that would be run at 2 a.m. and by about 4 a.m. the data would be populated in our environment that we needed for visualization, and this would be done consistently every single morning. So yeah, Python is incredibly useful, incredibly powerful, and it's really cool that this is essentially the key thing that we're going to be focusing on and leading Explore's students through as you get through the learning phase. While we are at Explore, there are 3 components that we need to know about with Python. Firstly, Python itself. It's a programming language, and it lets you work quickly to integrate systems more effectively. We're going to be using Python 3. It doesn't really matter what version of Python 3, but there are definitely key upgrades that have happened from Python 2 to Python 3 that will maybe make it a bit more challenging to be working through the coursework and the content that we if you have a previous version. So do just double check that you have version 3 point something. Anaconda, this is the world's most popular Python data science platform. You can run other things through Anaconda as well, which is quite fantastic. You'll see a interface for R also. So there are a lot of things that you can do with Anaconda, but essentially what we're going to know about for the most key relevance in this course is Conda being a package manager, ensuring all dependencies are managed and that everything essentially works. Why do we need Anaconda essentially? What we might find in certain Python packages is there are dependencies on other packages, and those dependencies might be incompatible with packages elsewhere. Bear in mind, Python is an open source language. There are contributions into libraries from all over the world, and there must be, when I last checked, I think there were 12,000 libraries. My number might be off by a factor of 2, but yeah, there were tens of thousands essentially that are available, that have been built up and are able to be used. Simply install from their source and then essentially plug and play once you have that in Python. So what you need to be aware of in some instances is that one package might break as a result of another package being around. So Anaconda helps us to keep all of this in check and to make sure that we are using the relevant packages in the relevant scripts that we. Finally, Jupyter. Project Jupyter exists to develop open source software, open standards, and services for interactive computing across dozens of programming languages. what's most relevant here is this allows us to run our code line by line, also have comments. You guys have been interacting with Jupyter all the way through, so you've already seen the advantages that you get from Jupyter, as opposed to imagine writing out a 100-line script, putting that into command, and then you either get something that works or something that doesn't work, and then you have to go back through your debugging. Whereas being able to run these components line by line really makes it a lot more interactive and user-friendly. All right, how are we bringing this in? Python is essentially a hacking skill. Hacking is one of the components of data science that is super, super critical. There are three pivotal elements in data science, and that is mathematics and stats. It's your domain-based expertise, so understanding the environment that you're working in, and also your hacking or programming skills. So with those in mind, what we are going to be looking through is trying to understand how all of these are going to fit together, and at Explore, we're going to be pushing you in each of these elements. We can't so much develop the subject-based or the domain-based expertise, because that's going to be very working in a medical field, whether you're working in insurance, whether you're working in credit products, whether you're working in banking, advertising, flights, whatever the situation is, you're going to need to develop domain-based expertise about that particular area. However, what we can do is we can teach you how to adapt, how to ask the right questions, how to engage in an entirely new domain. At this stage, we've begun to develop our understanding of data and database relationships, and we have introduced a data expertise, which will be used in conjunction with the domain knowledge that you will develop in whatever that environment is, that industry that you end up working in. Our i.e. programming, this is a toolbox for problem solving. Programming is applied algorithmic thinking. All right, there's a new term. What are we going to kind of interpret out of this idea of algorithmic thinking? Quote from Einstein, if I had an hour to solve a problem, I'd spend 55 minutes thinking about the problem and 5 minutes thinking about the solution. The idea here is, before you jump in and start trying to solve something, you need to fundamentally understand what it is you're trying to solve and how to break that down into various easy bite-sized steps. Start with a problem statement. Break the problem down into tangible, achievable steps. And I thought, what would be more appropriate to show you than an algorithm that sets up this entire course? An algorithm is a set of instructions to be followed to solve a problem. So an algorithm that we have already been exposed to, at least in parts and in theory, is the data science process, which is starting with the problem statement, data, processing your data, visualizing your data, then getting through to modeling and communicating. This is a step-by-step process. And again, even though this is fundamentally going to be covered in the machine learning sprint, let's just understand what we are working towards in this algorithmic setting. Whenever you are posed with a data science problem, you're going to start with a problem statement. Your stakeholders need to be identified, and we need to understand the value that exists in a solution that can be put forward. Ball pass to the data scientist. Data scientist needs to gather the data. We're going to get to data pre-processing, cleaning data, assuring quality, finally get to some visualization, interaction, and then from there, we're going to go through to modeling. Once the data is understood, and only once the data is understood, we're going to decide on the modeling methodology. We're going to do a test train split. We're going to build a model. We're going to choose hyperparameters in our model, we'll cover it later, and we're going to validate our model. Once that's done, there is zero value in everything that's done up to this point if you cannot communicate the information out to the stakeholders at the end of the day. communication of the results, recommendations, model deployment, and monitoring if and where required. This is an algorithmic approach to a data science problem. And in the same way, this is obviously a macro level picture. We are going to apply algorithmic thinking to micro level problems. And we can also consider this in a few applications that we potentially know about already. So a few use cases. Well, the first is the fact that Facebook actually knows relationship, and it's not by your relationship status. So Facebook will understand patterns from data. One of those things is the tracking of information coming from users on a day-to-day basis. And Facebook specifically observes an increase in interest, and that reverses into a relationship. Specifically, there's a peak of 1.67 posts per day, 12 days before the relationship begins, and a decline follows from there. Facebook is able to predict when you are about to start a relationship. And this is a very simplistic model. This is just essentially using one variable, one explanatory variable, as opposed to what Facebook really has access to. Also out of interest, if you go through Facebook settings, you can view a history log of all interactions you've had. And I'm not a very active Facebook user, but my history log was around, I think, 2.2 gigabytes, which is so wild when it's just a couple of pictures, posts, interactions, but it's all the likes, all the views that I've had, everyone who's been on my, all of everything. Facebook, astronomical amount of information that you are interacting with. It's why they're able to influence literal elections. If you guys haven't heard of Cambridge Analytica, look it up or ask me for the link. It's a very, very interesting piece of analysis. And it's also fascinating how the data in particular got gathered. Moving on from that, the idea of sentiment analysis. One of the tools in NLP, natural language processing, as a data scientist, you need to be able to interpret outcomes and communicate those results. So if you see the second graph on the right here, days before and after a relationship start, positive emotion level, single, in a relationship, can you interpret and infer some kind of insight out of this graph? There should be maybe two things that are immediately evident to you. The one is the fact that the positive emotions rise essentially as the relationship gets to the start, and immediately after the relationship starts, it sort of sinks a bit, and then it plateaus. So quite when you have access to this kind of information and the kind of conclusions that could be reached. Second use case, applying algorithms to unpack and wrangle data. So here we're transforming raw data to show valuable patterns. We're going to take our raw data, clean it, transform it, model it, get actionable views. So this is a graph below from the very, very first case of COVID in South Africa in 5th March 2020. And this is the output of a generalized script to pull data, construct metrics, graph the results, and these are indicative of the Western Cape's state of COVID. So what I've shown over here in bar, the red bar is the total number of confirmed positives. The blue bar is the portion of that are Western Cape, and the line is the positivity rate. Positivity rate is our tests that were done, what percentage came back positive. This measure has become quite erratic over the past month, so I opted not to plot that over there. But otherwise, essentially, I ran this script yesterday, and you can see where I got my original data from, GitHub repo of the NCID, that's the government database, essentially. So it's what the health department is releasing. And we can, where the Western Cape is right now, we are actually at an incredibly severe point. We have sort of plateaued over the last month, but we've plateaued on the level of the worst case environment that we were at in the second wave. And that was about 2.5-fold worse than where we were at our worst in the first wave. So just a plug to say, please guys, do be careful. Like, I know we're talking about Python and everything, and I am being a bit shameless show because this was constructed in R as opposed to Python, but just mentioning we are in a crisis period. Please look after yourselves and please be cautious as we go through. On a lighter note, we can also script automated responses. So chatbots, AI-generated memes. I've left a link over here for AI meme, and all of these are memes that I literally just generated by pressing a button and saying, create random meme. So I need to do my homework. And this one actually kind of makes sense if you're familiar with the meme environment. Not sure if I should wait for a midterm or not to death. Some of the memes, they're built by AI. The AI doesn't really understand the nuances of human interaction and syntax in English, so sometimes doesn't quite pull through, but certainly very interesting for amusement's sake. If you could stop messing with me, that would be great. Another killer, just works perfectly in terms of what the context of this meme would generally be. All right. Onto the idea, moving past these use cases. When we have a specific use case, there are always going to be many solutions that we can potentially have. We'll have one problem, in this case, write a function to sort any list. There are going to be several options for solutions that we could go through. And we want to do some kind of analysis, a complexity analysis specifically, to understand which is the best solution that we could go for. So I can consider timing, how much time it takes to run each of these implementations. We somehow need to measure our efficiency. And there are two ways that we can measure our efficiency: speed and space, or time efficiency versus space efficiency. We probably need to take into account both of these. One of the really cool things with the advance of computational power is that the capacity has been increasing, not actually, yes, exponentially. So this was mentioned in it's Moore's law. I think Gordon Moore established it. It was around I want to say 1968. He's one of the co-founders of Intel. You might recognize Intel as actually the chips that are used in Microsoft computers. So Gordon Moore essentially said in 68 that the computational power every 2 years is going to double. What he specifically said is the number of transistors in every device, or double the number of transistors, can be fitted into a device of the same size with a kind of timeline of 2 years. What that essentially means, though, is that every 2 years, computational power doubles. It stopped holding true over the last, say, 5 years or so, but going all the way through from like the late all the way through to the mid 2010s, it's astronomical how much computational power we have had at our disposal, especially relative to where we started. I mean, a original kind of a computer that could process 4 megabytes of information would have gone for $100,000 when it was originally produced in the 1970s. And it would only be the massive players in industry that would actually have access to this. Then we went through development. Essentially every 10 years, there's been an astronomical advance in computers. So first it was obviously the development of computers itself, then it was going into the development of the personalized computer. So people could actually have a personalized computer at their desk. It wasn't able to do all that much relative to current standards. Then we had the invention of the World Wide Web. We had computers going into mobile devices. So we've had this astronomical progression over the computation. Nonetheless, it is still very relevant to understand the efficiency of algorithms that we are using. So what we can do is we can look at the time that it takes to run and the space that is required in order to actually process. One of the ways that we can measure what we're doing is this thing called big O notation, which represents the maximum number of steps that an algorithm would require to find a solution. As a quick few examples, O1, order constant time, you can imagine no matter how big the data set is, no matter how many elements there are, it's always going to take the same amount of time. You can consider something along the lines of, I give a computer a list and it returns the last element in the list back to me. It's always going to take the same amount of time to just go to the list, find the last element. Linear time, this is when the time taken is going to increase, essentially based on how many elements are coming in the list or in the data. So you could imagine the calculation of taking the average. I am going to need to add an additional component into this average calculation. So this is the sum of x1, x2, x3, x4, x5, xn divided by n, and I'm going to get the average. Also, out of interest, that is a sample statistic, one of the components we're going to be covering over the next few weeks. Then we've got polynomial time, exponential time, where essentially when you add an extra element into the calculation, it's going to drastically impact the performance. Doing these kind of things might well help you to determine what the best algorithm is to solve your problem at hand. So what are we going to be covering over the coming few weeks? We are going to introduce data wrangling and statistical modeling in Python. Your submissions are going to be assessed through an auto-grader on Athena. You're going to have 12 tests in total, and this is going to ensure your comfort with the basic Python functionality in essence. My Mac is finally and wants to try and talk to me. Let me just close that. There are 12 tests. Sorry, I mentioned that. Within these tests, these are going to be testing core components of knowledge in Python. These are going to go from list comprehensions to implementing functions. So we're going to guide you through this process, and you're obviously going to have the normal pod meetings and your facilitators available to you. And there are all of the resources on DataCamp and Udemy. What's quite critical with understanding a new language, though, is just practice. There is no other way to become fluent in a language, spoken language, be it a programming language, other than practicing it. And there's going to be one project submission. In this project, you're going to be putting all the knowledge gathered over the course into the sprint to use. In this course, we're going to be teaching you and reinforcing consistency, legibility, application, efficiency. The building blocks we're going to be covering are basic functions, PEP8 coding, primitive data structures, what exactly is data, what are the options for Python data? We can look at, we've already been exposed to strings and floats and integers in SQL. Now we're going to go into the idea of data frames and lists and all of these beautiful things. The modules and packages, what these essentially help you to do is take pre-done algorithms and apply those algorithms so you don't have to do them from scratch yourself. Recursive functions, so function wants to call itself while it's running. And then scripting, which is compiling and executing Python code. And all of this is going to lead into data wrangling and statistical operations. Data wrangling essentially has 3 pillars in it. And we're going to be exploring Python's built-in features that can be integrated for data wrangling. we're going to start at the basic level of data cleansing. This is making sure your data makes sense. Always operate in data science with a GIGO approach. Garbage in, garbage out. It doesn't matter how amazing your computation is. It doesn't matter what your algorithms do. It doesn't matter how many terabytes of storage, how many gigabytes of RAM you have. If your data is bull, your output is going to be bull too. Data cleansing, detecting outliers, imputing missing values, typecasting, deduplication, value replacement. The list will go on, and you will be introduced to format your data and make it useful and appealing. Then we'll get to data frame operations, taking data from multiple sources, merging, aggregating that information together, normalizing databases if that is required, and enforcing database integrity should it be required for a problem. Lastly, feature engineering, creating new variables from existing attributes, properties, characteristics from the existing data. So we're transforming data based on our domain knowledge. As a by the by, Kaggle and Zindi competitions, there are essentially consistent results coming from any kind of supervised learning problem. All of those results operate with feature engineering. So essentially, you create your insights, you create your variables, I should say, to generate the insights that are most relevant. And that's where domain knowledge really comes through. What was quite fascinating was a Kaggle competition, I think it was 20, and it was predicting car crashes. Who is the most likely to be involved in a car crash? And what it turned out to be, this isn't kind of like the full answer, but what was quite critical to differentiate the winning individual from everyone else was how he had constructed new features. And those features were by car color. But what was very interesting was it was in particular taking unique colors. So anything that had a very, very low representation across the database, he put that into a unique color versus a typical, stereotypical, light, dark, what. And the logic, once you understand it, it sort of makes sense. If someone cares enough to go out and plaster their car in a unique shade of gold or crimson or whatever, they're a bit more invested than the average person, and they might be driving a bit safer. So it was fascinating. Knowledge is actually translated into the data, and it literally worked in terms of bringing about better performance of the models. Then we'll get into statistical analysis with Python. We'll be exploring how to integrate and use Python built-in libraries for statistical analysis. These are the concepts that we're going to be touching on: population metrics and sample statistics, probability plotting, visualization, and intuition, how to fit data into distribution, and how to use the packages that exist for statistical analysis. And finally, let's just touch on what your project is going to be when we get to it. So this is already going to be accessible, and you're able to view it and work through it. But the context is going to be, you are a data scientist at Eskom. Imagine you are one of the individuals who is able to help, who is able to make sure that accurate things can come out of it, if only the problems were this simple. Eskom requires certain metrics to be calculated for their analytical team. Your role is to build a couple of functions for Python, which will be used to process numeric and text data. So we're going to be touching on this idea. We're not going to go into too much detail, but we're going to be touching on NLP logic. So when you've got data coming in, and it's not numeric, but it's in a string format, we can start processing that in a slightly different way, and we can start interacting with it. And then you need to know, in order to start tackling these components, list manipulation, dictionaries, statistics and aggregation, function definitions, and how to code in a reasonable and interpretable manner. You're going to write 7 functions and 7 output metrics. You're going to submit those functions at the end of the sprint. So what you are building are going to be functions that take in a list or a pandas data frame, turn dictionaries and lists out. So there are going to be 3 functions here with increasing difficulty, 2 functions for calculated metrics. You can probably start on the first 2. Even in this first week, you should be able to get those done. So it'll be great if you start early on this, so you can start getting introduced to what's going to be coming over the period or over these 4 weeks in the sprint. And then we're going to get into Twitter data processing. So this is text and lang. So your functions are going to be able to take in text data, either again as a list or a data frame, and return out usable information. So this information that you're going to be returning is going to do NLP computations and NLP, natural language processing, on this input and be able to give useful, pragmatic output. Just as an appendix, if you were interested in COVID numbers, we can see how badly KZN is on trajectory to be right now. Western Cape has been essentially stagnant, but growing slightly. If we look relative to 30 days ago, KZN looking astronomically bad, and Gauteng has been in a period of recovery. You can also see Western Cape's death figures have unfortunately been growing consistently for the last 3 months. Otherwise, also a bit of an appendix, just a couple of that I might have referenced but not directly used images or such from in the presentation. Cool. That is it from me. Are there any questions? Please unmute yourself and ask questions. Yeah. Let me just double check. Okay, I'm not seeing anything in the chat.
To preempt a question that may pop up, for the predict submission, it works exactly the same way as the autograder. So it is an autograded submission for the predict that will happen on the predict page. So on your predict tab on Athena, when you enter that space, you will see a submission button that takes you through an autograder. For any autograded submission of any kind, whether it is a test or a predict, you can submit multiple times until the due date of whatever it is that you're submitting. Something to keep in mind is that each submission overwrites the previous one, so you need to keep anything that you think is valuable, because Athena won't keep it for you, but you can submit multiple times.
Cool. Thank you, Joanne.
Sorry, Joanne, I just want to confirm, you're saying, is this with reference to the predict?
Also, yes.
Sorry, yes, Gabe.
Everything you submit on the autograder, so be it any of the tests or be it the predict, you can submit essentially infinite times, and you can utilize this. In fact, you should utilize this very differently to how you've utilized test submissions before. So one of the notes for an autograder is it might look for some specific in terms of the output coming. So for example, you might have the correct output, but it's expected to be in a list format and you've outputted it as a dictionary, or you've outputted it as a data frame. The autograder is going to say that there's an error and this is why there's an error. So it's going to essentially give you a 0%, but that's going to allow you to then update your code, make sure you're doing the thing that is required by the autograder, and then resubmit. So do use the as you're kind of working through. If you think you have the right answer, cool, double check it by submitting it, see if it comes out with an error or if it works. And you can essentially use the autograder as one of the resources at your disposal.
So just for clarification purposes, say I do my first submission, I get 60%, then I can overwrite that with the second submission, and my first submission won't have an effect on my final grade.
Yes, very much.
And that that includes tests and the predict and the exam.
Yeah, I was gonna show you, but I realized that all of my on my work computer. This is my personal one. Yes. So I just tested this out myself before kind of talking about this. And yes, you can submit something as many times as you want. And each time you submit, it's going to be the mark coming from that submission that overwrites everything before. So nothing matters except for your final submission.
Was this the same for SQL as well, the SQL sprint?
No.
Because for the SQL sprint, you were answering a test. So you weren't so much submitting your notebooks for grading, you were submitting your notebooks for moderation. So the reason that we asked for your notebooks to be submitted there was so that it was possible to backtrack and determine for CETA purposes that all of the engagement had been reasonable and ethical, and that people weren't, for example, in the same workbook as someone else, because as an individual test, it does need to be answered and tackled individually. So the answers and the mark would have come from what you put down on the test, so on the MCQs. And if you were to redo the test, it would not count for your belt points at all. It would be able to be utilized, Joanne can correct me, for CETA purposes, so it is still relevant.
Correct.
Do tests and get the 70%. But then the notebook itself doesn't matter except for moderation purposes. So to ensure that, as I say, everything has been answered ethically.
Okay, now thanks for the clarification.
Cool.
I just don't know on your side. Sorry, James.
Go for it.
Like you throughout the presentation, there were points you like cut off for like a few seconds.
Oh no.
Yeah.
It's frustrating.
Yeah, no, but it's okay.
How many did I lose each time?
Just a couple seconds.
Okay.
You weren't. We could still gain the context of what you were saying.
Okay. Cool. Thanks for the heads up. Okay. One other note from me is Thursday is throwing you into a bit of a deep end. So Thursday, you're going to be covering the idea of big O notation, and just selecting from a couple of different algorithms, essentially the listing algorithms, what is going to be working best in different situations. In particular, when you have a larger and larger list, what sorting algorithms should you be using? So it is throwing you in the deep end because these are essentially simple algorithms relative to some of the others that are mentioned. So they are quite theoretical. I don't want you to feel overwhelmed when you get to them. The tests do not go into that level of complexity. So it's still very you unpack and work through and get as comfortable with them as you can be, but don't stress about needing to memorize them or needing to understand every single line that you are going through. It is a lot that you're going to be working through on Thursday with big O notation and sorting algorithms in particular. And we're also going to set up a webinar on, did we say Wednesday, Joanne? To cover some of that and to preempt a bit of overwhelming environment that's going to appear on Thursday. Cool.
Can I just clarify something for the previous sprint as well, SQL?
Yeah.
Where like for some tests, and I know the exam and predict, there was an option to submit your notebook, but it wasn't compulsory. Can you just confirm that?
So
go, Joanne. Sorry.
If the option existed to submit your notebook, you needed to submit your notebook. It wasn't optional.
Oh, okay. No, I understand.
Yeah. So if you haven't submitted your notebooks for tests that required it, you can just go back and using the retry, submit your notebook there.
Okay, thanks.
Cool. There's time for one more question, if there are any. And otherwise, awesome. Cool. Thank you so much, everyone. I hope that you have a wonderful